The blades of a wind turbine are affected by four forces: drag, lift, centrifugal, and gravitational forces. Drag forces are caused by the air molecules that hit the surface of the blade facing the wind. A major component of the drag force acts in the direction that is parallel to the main shaft of the rotor. The magnitude of the drag force varies with the wind speed and the size and shape of the blade. Drag forces have a cantilever beam effect on the blade, causing the maximum stress at the joint between the blade and the hub, which is connected to the main shaft of the wind turbine. When the wind passes over the blade, the pressure difference between the front and back of the blade causes the lift forces. A major component of the lift force acts in the ever-changing tangential direction as the rotor rotates. The magnitude of the lift force varies with the wind speed, the size and shape of the blade. As generator load increases, the amount of lift must also increase, within the limits of prevailing wind conditions. Lift forces also have a cantilever beam effect on the blade, causing the maximum stress at the joint between the blade and the hub, which is connected to the main shaft of the wind turbine. The drag forces and the lift forces are perpendicular to each other. So are their cantilever beam effects on the blades. The velocity of each particle inside the blade changes direction as the rotor rotates. This change of direction is a form of acceleration of the particle toward the center, or axis, that the blade revolves around. This acceleration is caused by the centripetal force. However, for rotating systems, such as wind turbine blades and their hub, it is common to explain the blade's stress due to rotation in terms of the fictional centrifugal inertial force, which is equal in magnitude to the centripetal force, but in the opposite direction. The tensile stress builds up to reach its maximum at the joint between the blade and the hub. The centrifugal forces are always in the radial direction, causing tensile stress throughout the whole blade, from the root to the tip. The centrifugal forces vary with the size, shape, and mass density of the blade, as well as the angular speed of the rotor. Centrifugal forces increase rapidly as the rotor gains speed. The gravitational forces acting on any part of the blade vary with the mass density, size, and shape of the blade. The gravitational forces are always toward the center of the Earth. Therefore, the gravitational forces have a variable effect on the blade as the rotor rotates. Maximum tensile or compressive stresses occur along the radial direction when the blade is vertical, while maximum bending stress happens when the blade is horizontal. The maximum stress caused by the drag forces, the lift forces, the centrifugal forces, and the gravitational forces concentrates at the joint between the blade and the hub. Therefore, the proper installation and maintenance of the joints between the root of the blades and the hub are critical to the safe operation of wind turbines.